Hello. Today we are going to be solving Leetcode 23. With this, we have been given a list of sorted lists, and we've been asked to merge them into one single list. So let's take a look. For example, we have 8 sets of lists, right? We have list 1, list 2, list 3, list 4, list 5, 6, 7, and list 8, right? If these are representation of sorted lists and we want to sort them, we'll first, for example, merge these two lists, right? So if we merge this into this, we will have list 1 and 2. We will still have list 2 standing here. And then we merge these two. So we have list 3 and 4. We still have list 4. We will merge these two. We have list 5 and 6. Still have list 6. And then we'll merge list 7, 8. We'll still have list 8. Now, with array, we would know that in this case, after merging these two, we will jump 2 steps, right? So from here, after merging these two, we jump 1, 1, 2 to get to 3 to merge 3 and 4, and then we jump 1, 2 to get to 5, merge them, right? But also we will see that we are merging these ones, right? So this just merging these ones, and we're merging the next ones, right? But the iteration step is 2, right? That's something that we must take note of because we're taking them in sets of 2. Now, after we've merged this, the next step, we are going to be merging these and this, and then this and this, because those are the relevant ones right now. So merging this, we are going to have 1, 2, 3, and 4, and then this is going to have 1, 5, 6, 7, 8. We are still going to have L6, we're going to have L7, 8, we are going to have L8. Same applies here. We're going to have L2, have L3, 4, we're still going to have L4, right? The next one, we're going to merge this and this, right? But again, we will see, like we are merging one step here. This time we are merging, we're jumping 1, 2. So here is plus 2, here is plus 2, right? And here we are jumping 4 steps, right? From here we're going 1, 2, 3, 4. We're jumping from here, we're jumping 1, 2, 3, 4 to get to this one, so it's plus 4. So the iterative step increases after every iteration, right? After this iteration is 2, the next iteration is 4, and then the last iteration is 4. Also, we are merging here, we're merging the first and second. The second iteration, we will be merging the first and the fourth, right? The first and the second. Well, technically the second, but it is like the third, the first and the third, and then here it will be the first and the fourth, right? So that is how we are going to merge all of these lists into one list. At the end of the day, we are going to just return the list of the 0, right? If it is truly a list, right? But the thing you need to take into account is you imagine these twos, you imagine them in pairs, and then you iterate in 2 steps. Here, you imagine them in pairs, but you imagine this one and this one. You need to jump 2 steps to merge them, right? But in sorted list, the algorithm you need to do a sorted list is merge sort, right? So we are going to use merge sort to be merging these 2 lists. Another thing that you need to be familiar, this is the most important thing that you need to get yourself familiarized with. and also no merge sort algorithm. So with this one, we consider if we merge the first two, we are going to have 1, 1, 3, 4, 4. Now if we add the second one to it, you're going to get 1, 1. There's a 2 here. There's a 3, 4, 4, and 6. Right. So that is exactly what we are going to do. So let's look at how we are going to represent that in code. Let's get our merge sort algorithm for linked lists. So we have L1 and L2. So while we still have L1 and L2, if the value of L1 is less than or equal to the value of L2, if the value of L1 is less than or equal to the value of L2, so now let's set our dummy head, right? So let's say pointer is equal to head, which is equal to a dummy head of node. Right, so if that is the case, it means pointer dot next is equal to L1, and L1 is equal to L1 dot next. If that is not the case, we do the same thing for L2. So pointer will be equal to L2, and L2 will be equal to L2 dot next. Now pointer moves forward. Pointer now points to pointer is now equal to pointer dot next. Now whatever is left, so pointer will now be equal to whatever is left. Pointer dot next will be equal to L1 if L1 is not none, else L2, and then we return head dot next. Now this is standard merge sort algorithm for linked lists. Right, now let's go to, let's set step is equal to 1. We are going to be stepping with 1, right? Let's get the length of the list, which is going to be like right. So let's call it right. It's equal to length of lists. So while step is less than right, for I in the range from 0 to the length of the array, or yes, the length of the array, let's just write minus step the iteration step is going to be 2, right? We jump from here to here, right? 2. So it's going to be step times 2. List 1 is going to be merge sorts of lists I and lists I per step. It's one step, right? One step. This time it's going to be 2 steps when we come down here, right? So, and then when we come down here, it's going to be 4 steps. So it's 1. You see that it's multiples of 2, right? So after every iteration, step is going to increment by 2. So after that, we return the lists of the first element if this is an actual list. Else just return none. Okay, so this is how you solve merge case sorted lists. Let's see if I'm missing anything. What did I miss this time around? So while step is less than right for I in range, step times 2, list I is I and I step, and step is multiple of 2. If right is greater than 0, else none. Did I make a mistake in my mesh sort algorithm? This list of value, L1 value is less than that. Pointer dot next is L1. L1 is equal to L1 dot next. Plus pointer dot next. This is where I missed it. Pointer dot next is equal to L2, and L2 is equal to L1. I think that is it. Yes. So this is how you solve merge case or sorted lists. You missed something here, that is why. Well, thank you very much. Thanks for watching. See you in the next one.